In this video, we'll be rigging one of our characters. So here I have this nice character model which will be one of the NPCs in our game, but before it can be animated, we first need to build a rig. The rig is basically the skeleton of a character mesh, which you manipulate to control your character and make animations. I'm going to change the bone display in the viewport to stick and check the in-front option to make it easier to see on the mesh. I'm going to start off the rig by making a bone at the base of his feet, which I will call the root bone. This bone is typically the highest bone in the parenting hierarchy and is used for when you're animating character movements like walking or running. From here, I'm going to duplicate this bone and move it to around the hip area and scale it down. I'm then going to duplicate this hip bone and flip it around. This is going to act as our hip angle controller, so we can control the hips independently from the torso. I'm then going to duplicate this hip controller bone and move it to around the thigh area, then extrude this bone out to make our shin bone. As you can see here, there isn't actually any leg mesh underneath his pants. This is to avoid having any peek through when we're deforming the rig during animation, and to save on polygon count since you don't need to see what's underneath there anyway. I'm naming my bones with the .l suffix, which is important later when we go to mirror this rig. We'll just speed through the torso section because it's pretty simple. In a real human skeleton, the spine is made up of 24 articulated vertebrae, but if you look at some reference photos of people bending, the torso bend can be divided into roughly 3 sections, so we'll approximate the spine bend with only 3 bones instead of 24. Similarly, we'll only use 1 bone for the neck and 1 for the head. Next come the arms. You can see on our character here that the arm mesh is actually separated from the torso. In a mesh where the arms are connected, there's some additional work that needs to be done to get nice deformations in the shoulders, but because of the unlit shading style that we're using, we can get away with this ball joint style arm. I'm just using the 3D cursor to help me line up the bones with their vertices. We'll just extrude these bones out to make the upper and lower arm, then the hand, and finally duplicate these bones to make the individual fingers. I changed the shading in the viewport just so I can better visualize the fingers as I align these finger bones. Something important to note is that we want our finger bone rolls to be aligned with the x-axis. Real fingers only bend along one axis of the finger joint, so that when you want to bend the finger, all you have to do is rotate all the finger bones along the x-axis. Here I'm adding the controller bones for the inverse kinematics constraint that we'll be adding to the legs. I place a bone directly in front of the knee along the x-axis, and another one behind the foot. We'll be controlling the character's legs with these bones, rather than the ones in the legs. I use a similar setup for the arm IK. We'll just fast forward through this part while I work on the hands. They're all built the same, it's just tedious to align and rename them all. Once we finish building the first half of the rig, we can select all the bones and go to Armature and Symmetrize, which will create a mirror of all the bones, as well as renaming them to the opposite side, as long as you followed a Blender recognized naming convention when you were naming all of your bones, either a dot or an underscore followed by an L or R to denote left or right. Now it's time to add our inverse kinematic constraint. We'll select the last bone we want in our IK chain and add a constraint in the Bone tab. We will then select which bone will act as our IK controller and which one will be our pole target. This constraint calculates and rotates the other bones in the chain to meet at the controller. The pole target allows you to alter the direction that the bend points. You can change things like how many bones should be affected in the chain by altering the chain length option, and you can also change the influence the constraint has on the bones, as well as the pole angle if you need to make any adjustments. Once that's done, you can then drag your controller around to see if you're happy with how the bones are bending. Now that we have the basic rig created, we can move on to weight painting, which is basically denoting which vertices should follow which bone. The first thing we should do is go through all our controller bones and deselect the deform option. These bones are purely for controlling our rig, so we don't want them to have any direct influence on deforming the mesh. Then we need to parent our mesh to the rig, which you can do by selecting your object in object mode, then shift selecting your armature, then pressing Ctrl P on your keyboard and selecting parent with empty groups. There is also an option called automatic weights, where Blender will automatically calculate your weights for you, which is super handy and works pretty well if your mesh is relatively simple. However, if you have parts of the mesh that overlap or irregular topology, it's easier to do the weight painting yourself rather than having to fix what Blender has already assigned. Now to go into weight paint mode, first select the bone you want to work with in pose mode, then shift select the mesh. With both of these selected, go to the Mode Change tab and click on the weight paint mode. In weight paint mode, you can choose which part of the mesh you want to be influenced by the selected bone by painting weight onto the mesh. There are two buttons on the top left for face and vertex select, in case you want to selectively paint on only certain faces or vertices. In weight paint mode, you can add weight using the Add brush and likewise subtract weight by using the Subtract brush. The weight values go from blue, representing 0 for no influence, to red, which represents full weight or a value of 1. In symmetrical rigs, there is also an option in the Tools tab labeled as X Mirror, which will mirror what you do on one side to the other. It's super handy as you won't have to re-weight the other side of your rig, and also ensures that the weight of your rig is equivalent on both sides. Additionally, you can change the size and strength of your brush to better suit your needs. From then on, it's just a lot of painting and adjusting until you're satisfied with how your mesh deforms. Weight painting does take a good amount of time, but hopefully by the end of it, your rig will let you pose your character the way you want it to. I hope this was helpful in some way. Thanks for watching.